quickly swapping the thing. I will introduce you. Oh, I thought we would do the code of conduct after the. Yeah. Okay. This is Dante, and he is working on Toronto Mesh.
Unmute ourselves. Oh, that's pretty good. Hi, my name is Dante. I joined Toronto Mesh 2 years ago, and I am currently the central organization lead. Toronto Mesh is a group of volunteers that was started at Civic Tech Toronto in 2016. Our work includes, among other things, building hardware and software solutions for networking applications, also organizing outreach activities with a focus on technical literacy. Today, I will talk about some ways in which we can build a better web together. First, I will talk about some of the challenges that the internet is facing today. Then, I will discuss some of the solutions being explored to address them and how our work relates to them. Finally, I will go over some of the ways in which you can contribute. I will only cover topics from a very high level, so I apologize if I gloss over some things. We can discuss plenty afterwards. I'll stick around all night. So, let's get started. What does the web look like today? Let's start with infrastructure. When I say infrastructure, I mean everything that lives on the physical layer. So cables and fiber, radios, antennas, and everything in between. Most of the infrastructure that we use to go online is managed by internet service providers, or ISPs, and in many cases regulated by some government authority. Both of them engage in filtering, censorship, and surveillance. Filtering may mean targeting certain kinds of traffic and slowing it down or speeding it up. Censorship is another kind of filtering. Censorship at the infrastructural level is mostly dictated and in many cases carried out by government agencies. This is a flowchart that the Chinese government uses to assess online content. When I say surveillance, surveillance covers all types of data collection, whether it's for profit or for social control. Let's move on to services. When I say services, I mean everything in the digital layer. So everything we can call software, apps, websites, desktop programs, just ones and zeros. Think of the websites that you visit and the apps that you use on your phone. Many of these services are controlled by centralized systems and that may also engage in censorship and surveillance practices. So why is centralization a bad thing? Think of these three. Google, Facebook, and Amazon have come to dominate the services that support the internet. This market dominance has turned these companies into gatekeepers of information. So we have to trust them to use their power fairly and responsibly. They do not. In fact, all of them have huge financial incentives to not only monitor our behavior, but also manipulate it whenever possible. Think about the power they yield when it comes to content moderation and censorship. We are relying on businesses to dictate what content should and should not be blocked, and when, and where. These same businesses that not only claim ownership of our personal data, but also share with government agencies and marketing firms. So we have identified some issues. What can we do about them? Before we can begin any meaningful work, we must recognize that technology has no purpose without the people using it. So the key part to building a better web is our community. And by community, I mean any group of people, our family, or our friends, or our neighborhood. Yeah, so how do we prepare our community for tomorrow's web? I see three major steps, and first off, we need people to become aware of the issues we have seen. Developing literacy would be the next step. Maybe you want to become familiar with government policy, build some networking know-how, or research the business model of your favorite social network. Finally, a community can begin working on changes. They may opt for adopting less intrusive online services, maybe pushing for adequate legislation, or even building a network. So that covers community. Before I go into infrastructure and services, to better understand the ideas behind tomorrow's technologies, there are three terms that I need to explain. The first one is the concept of open source. Open source means the data of any given product or service is available for study, analysis, and in many cases, even modification. One example is the governance documents that Toronto Mesh makes public through GitHub. Open source covers pretty much every area, so software, hardware, governance, what have you. The next term is peer-to-peer. In a peer-to-peer system, members of a group or network can communicate with one another instead of relying on a centralized service. One example is Ride Austin, a ride-sharing co-op that links riders directly to vehicle operators. And last is the concept of a mesh network. Members of a mesh network, also called nodes, connect to as many other nodes as possible and cooperate with one another to efficiently transmit data back and forth. That map there is an example of a mesh network, and that's Geophysics in the south of Spain. Now let's take a look at a couple of models to see how mesh networking work in practice. This is an oversimplified model of how we access the internet today. We connect to an ISP, and in turn, they connect us to a content provider. What would it look like with a mesh network? Well, this is just one option. Using a mesh network, only a few computers require an internet connection, and all of its members can still access content. With these ideas in mind, let's talk about infrastructure in tomorrow's web. Communities are exploring different ownership models for infrastructure. And some are leveraging mesh technologies to build networks based on their needs, and others are pushing local governments to provide affordable internet access. Two examples of community networks are FryFunk and New York City Mesh. FryFunk is a non-commercial grassroots initiative to support free computer networks in Germany, and New York City Mesh, on the right, is a nonprofit project of the Internet Society. The main point of community networks is that having control of a network at the community level lowers the incentive for discriminating against network traffic, and it makes censorship and surveillance harder to implement. Now, what about services? I will stop talking about services and instead focus on protocols. A protocol is just a set of rules that computers agree on in order to better communicate with one another, specifically open source peer-to-peer protocols. So there are many of them out there, but today I will talk about two. Think about how we publish and access content on social networks. Let's say a friend of mine posts a picture on Facebook. Facebook will add that post to my feed, and I'll see it next time I log in, along with a bunch of ads. So can we think of another way to share our data? Let's go back to our earlier model for content access. Using peer-to-peer protocols, we are able to do away with centralized content providers and share content directly with one another. So one protocol that allows us to do this is called Scuttlebutt. Scuttlebutt is a protocol for secure communications, on top of which different kinds of applications can be built. Applications that work well offline and that no one person can control. The Scuttlebutt clients connect directly from peer to peer, so this means I hold my friend's data and they hold mine. Because there are no central servers, it is much harder to collect data on a massive scale. There is no company for a tech giant to buy, and no single database for governments to data mine. Like I said, there are many clients for the Scuttlebutt protocol. This is just one of them. It's called Patchwork. I'm running it on my computer. Can we apply the same concept to other online services? How about file sharing? The Interplanetary File System, or IPFS for short, is a protocol that we use to host and share files. So if I share a file with a friend of mine through IPFS, a second friend can download it from both of us at the same time and even stream it. IPFS is being used to share talks recorded during last year's Our Networks conference. And just like with Scuttlebutt, there are several clients built on top of the IPFS protocol. So this is a screenshot of an IPFS desktop app. I was playing with it when I was putting this presentation together, and I found a huge image data set from the Apollo missions and a collection of XKCD comics. Okay, so we've covered the ingredients for a better web. Where does Toronto Mesh fit in? I'll start with infrastructure. We have developed a platform using open source software that people can use as a reference to build a mesh network. On the hardware side, it consists of a single board computer and a mesh-enabled Wi-Fi dongle like the ones shown in the picture. For protocols, the platform has a number of modules to choose from. You can pick one or two network protocols that will route and encrypt your traffic. You can also install either Scuttlebutt or IPFS or a variety of monitoring tools. The screenshot on the right shows the landing page for the node I have running at home. On the community side, we hold monthly meetups where we bring together people looking to join a network, and we help them better understand the technology behind the node platform. I'll just give a quick shout out to Free Geek Toronto. They've been hosting us for over a year now, so you should check them out. They're doing great work. Also, last year we conducted a 6-week course at Fort York Library where participants learned about networking, peer-to-peer, and community organizing. At this stage, we don't have a permanent wireless link between any two nodes, so our mesh is linked through the internet. The side on the right shows all the nodes that are connected to Toronto Mesh at any given time, which brings us to our last section, Toronto Mesh and you. If you are interested in joining our group, there are tons of things to do. Maybe you can help us grow awareness around peer-to-peer networks and alternatives to centralized systems. Maybe you want to host a mesh node at your home or office to help us test and grow the network. If we're lucky, you'll be within range of an existing node. If you're into technical stuff, we have lots of ideas to implement on both hardware and software. And we also have a healthy backlog of design-related tasks, from website design to branding and stickers, what have you. I will leave you with the words of Sir Tim Berners-Lee on the 30th anniversary of the web last month. The web is for everyone, and collectively we hold the power to change it. It won't be easy, but if we dream a little and work a lot, we can get the web we want. I have brought a couple of notes with me today. If anyone wants to take a look or discuss peer-to-peer systems or ask about contributing to Toronto Mesh, I'll be around. If you want to reach out afterwards, hop on our chat and come say hi. Thank you. How are we for time for questions? If anyone has any questions, otherwise,
We've got plenty of time for questions. So, who wants to ask the first question?
I was just curious about the pairing of the nodes. Are you using, like, you say the pairing happens over the internet.
Yes.
Are you doing like OSR or anything like that, like wirelessly to pair?
We're using one of two networking protocols. One of them is CJDNS, and the other one is CJDNS, and the other one is called Yggdrasil, like the world tree from Thor. And both of them, they do addressing, routing, and encryption. So it's a bundle of networking tools that both of them do. But
Are they aware from the wirelessly at all?
or just like through, like each of us has internet access, so we just go through our internet, and then it resurfaces on the other side. Is that clear?
Yeah.
Ish?
Yeah, it's quite well.
Okay.
Okay. I think PatCon had a question.
Yeah, I guess I was wondering if you could explain the rationale of going through the internet with a mesh network. It's just that it might sound unintuitive. Sort of.
If we had a number of nodes within line of sight with each other, excuse me, I'm gonna have a sip of water here. I'm parched. Sorry. It's a matter of that. As a matter of fact, we have no two nodes within line of sight of each other. If we did, we would have like permanent links and just hopping on from one to the other. Or if we were in close proximity with one another, we can lay down a cable going from node to node. Otherwise, we are relying on existing infrastructure to get us from one point to another. Is that good? Okay. I think I see a gentleman over here. Yeah? Okay. I don't think we have a data governance system per se. You mean like the stuff that we make public through GitHub, or? Yes, I don't think we have a system like that in place right now, just due to the size of the network that we have right now. I think we have yet to hit like more than 20 nodes at any one time. So I think anyone who sets up a node at this point is pretty much responsible for what kind of traffic goes through that one node. Is that? Problem?
Okay, next question.
And just, could you go back to the slide with the hardware on it and just say a little bit more,
Oh,
point
yeah,
at
sure.
which one's which?
So
and
the one on the left here, that's a Raspberry Pi 3 with the USB dongle. I think that's an off-the-shelf one. And the one on the right, I think that's an Orange Pi 0, one of the two. And we have tested maybe like over a dozen different boards that we know that the protocols work and that the software stack will run on them, as well as like the software that we build on top of that. So yeah, Raspberry Pi 3, Orange Pi, and I think the Wi-Fi dongle on the one on the Orange Pi, that's like a special one that we order from China. And The one on the right, though, it's from a test that we ran close to Fort York Library last year to test the radio link between two bridges. And that was like a healthy 100-meter distance there, where this thing on the, what is this, the white? Can't even see it, either way. Like this thing here, that's an antenna. We were testing hardware from a group called Libra Mesh. They're building a router that's built from scratch for mesh networks called the Libra router, and we got our hands on a prototype radio that's what we were testing that one time. Is that good? No?
What's the range on those ones?
On the little ones, I think you might be lucky if you get more than 20 meters with it's USB powered. So there's and they're omnidirectional, so you lose that power over your diameter, the perimeter of the range. It's the directional antennas that will give you that range. But you also need to think about where you're going to set them up, and you need that line of sight to point them at the right node.
Next question.
Is there anything in the Philly or NYC mesh that you're trying to replicate here that might work?
So Philly was first. Philly, we worked together with people in the Philly mesh group, and I think they're also just starting to grow their user base. But we work very closely with them. The New York City mesh operates more as an ISP, so where you do pay to access the service, and because it's not volunteer run, there's some certain expectations of the network is going to be operational, and there are parties responsible for maintaining the super nodes that a bunch of people are pointing their antennas at. So I think we don't have the numbers yet, but once we get there, then we'll have to start thinking about what model we're going to go with.
Next question.
Any thoughts on how the communities in Toronto versus other cities are the same or different, or how they came about or how they run?
I don't have that much information. I know that one is the need. So if there's a demand for it, these things will pop up. But another one is also timing. So like the Freifunk network in Germany, they've been around for a number of years, right? So I think they also have some time ahead of us that they got there. I think I saw a hand. Okay.
My question was about what are the kind of frequencies radio? What are the radio frequencies this is using? Is it using existing Wi-Fi channels?
Yeah, we're just using our licensed bands. So most of the off-the-shelf radios that we use, they're just 2.4 gigahertz. The special Chinese ordered ones, they run 2.4 and 5 gigahertz. But we're trying to not need a license to operate these radios. I think I saw Matt in the back there, or maybe not. I don't know. No, we're good. Oh, question?
One more.
Oh.
What other bands have you been playing with? Because there's bands in technology like LoRa, which is basically kilometer distances.
Yeah, well, it's you kind of lose the data rate there when you switch to a lower frequency. So you get the range, but the throughput is not as high. We do include LoRa in our workshops just so you can better understand how to work with these kind of technologies. But it's not something that we incorporate in our main software stack.
Another question. Thanks. Have either you or the network in Germany received any legal challenges?
The Freifunk Germany, I know that from the get-go they knew they were going to be challenged by a coalition of ISPs. So from the get-go they just set some money aside to deal with that kind of stuff in the future. And at some point when they noticed that the writing was on the wall, I don't really know how they did it, but they kind of said, we're suing you ISPs for not suing us because we're gonna we know you're just waiting for the right moment so you can take us out. So apparently they took them to court and they won the challenge. So they're operating just fine right now. I think there are other challenges with any model you can think of, but at least they had the foresight to think about it in advance. Not yet, and I think it could happen. It could very well happen. It's just a matter of numbers. The moment we become truly visible to one of the big three or regulatory agencies, someone's gonna come knocking on our door. But I would be very happy if that's the kind of problem we had. Yeah.
Hi. What would be your sort of, for Toronto Mesh, what would be like the pie in the sky awesome goal? What do you really want to do with all this technology?
I would like, there's so many things. I would like a community that gets together and let's talk about like in a rural area where people can come together instead of begging Bell or Rogers to lay down fiber down to their driveway. They can get together and lay down fiber by themselves or just set up radios that operate between properties. That's in like open land in the city. I would very much like to have like a number of buildings get together and say, I'm gonna put a node at this balcony on each of the sides on the building, and we're just gonna aim it out and link with that building and that building over there, and from there just propagate the connection down the building. It's a number of, there's a lot of pies in the skies, but for now we're just looking for people who are close together in the city, like any two people in one city, that's all we need to start to set up like a permanent link.
Okay, I am going to take the Master of Ceremonies privilege and ask the final question. How transparent do you plan, hope, or expect to make the software built on top of this to the end user? Obviously, there are going to be some differences, for instance, in using a Git on a mesh network versus using Git on on the current GitLab or GitHub platforms. But how different do you expect this will be?
That it's partly related to user experience, and that's something we're working on in terms of making it easier for the user to actually interact with how they're pulling the software, how they're installing the software stack that we make available. But like as of right now, the latest software that we're running on the nodes, they're all available on GitHub. And the guides that we have, I want to say they're pretty good. Like they're easy to follow as long as you know the computer lingo behind it. But it's a matter of user experience and working that into the whole like setup process.
Okay, thank you very much indeed. We appreciate this update. And
Thank
we'll
you.
look forward to more.
Thank you very much.